Hello, my name is Maciej Cieślak and I'm an engineer at TGEN. Today I will be showing you one of our inbuilt tools which are available from within ePOP Desktop. The tool that I will be showcasing is called TGEN, which stands for Transmission Generator. Transmission Generator is a tool that allows transmission designers to have one-stop shop to generate concepts and simulate their performance at a system level. So in this project, we will be generating transmission concepts that will be in line with our predefined requirements, and we will be performing further analyses with these concepts within ePOP Desktop. Using this approach, we're able to quickly generate multiple concepts and investigate their performance. As an outcome of this study, we will be able to evaluate the system level performance and choose the best proposition for the component for our system architecture. Let's move into within ePOP Desktop and start the project. I have loaded an empty project into our data library. However, this project already has some key components within it. We've got a vehicle loaded, we've got over 25 motors, and we have two seed inverters. This is a project that looks at performance of a small C segment battery powered vehicle, and we would like to size a transmission for that vehicle. We know that the power of the powertrain in that vehicle is 150 kilowatts, and that is what we will be trying to size the transmission for. TGEN is available within Transmission tab and is launched when you select New Transmission. TGEN allows you to build transmissions of different architectures, from one speed, one stage, all the way down to multiple stage transmissions, such as two-speed, three-stage, or three-speed, three-stage transmissions. In our case, we will look at a very popular proposition within battery electric vehicles, which is one-speed, one-stage transmission. From my previous analysis of this example, I know that I will need a minimum torque for this transmission of 300 Newton meters and a maximum torque range of 500 Newton meters. I will keep the input torque step at 10 Newton meters. Here I can select overall ratio targets, and I will select the targets to be from 5 to 15 ratio on the first stage, and 3 to 10 with a step of 1 at the top stage. Next, I will generate ratios. As we can see, the software has generated 10 concepts, 10 ratios, and according to these, concepts will be generated. Let's generate the concepts then. Generating concepts takes a while. However, we can see that 210 different transmissions where concept transmissions were generated. The next step, we can inspect the two-dimensional side view of the generated concepts. We can inspect them for all of the input torque ranges, and we can also view the loss maps for all the transmissions, meshes, and bearings. Within TGEN, it is possible to define other things such as the helix angles, pressure angles, or oil levels to define losses even more accurately. It is also possible to define oil viscosity. We also allow our users to define preload on the bearings on the shafts. As we can see in the data library, we have 210 transmissions generated and added to the library. Next, we can use these to create a study to generate some valid component combinations. And to do that, we need to select all of our transmissions and select some filters for the vehicle that we are investigating. I have added a minimum wheel speed of 180 and maximum of 220 kilometers per hour, and wheel torque between 3400 and 3600 newton meters. If we calculate the study cases, we can see that the software tells us how many failed and successful combinations are there for these components. As we can see, there are 102 successful combinations that will build meaningful architectures. Next, we can run an ePOP study to further explore performance of each of those architectures. In my case, to save time, I have already pre-run the study with these parameters, so we can inspect the results immediately. To do that, I will open our results inspector viewer called ePOP viewer. As we can see, the results have been loaded into ePOP viewer, and we can inspect quite interesting interesting KPIs for all these architectures. We can look at total powertrain mass, how it changes, and how total cost of ownership is with the relation of the powertrain total mass. But as you can see, we don't have any signals that are relating to transmissions. To add signals that are related to transmissions, we need to go into our signal manager and select any of the parameters that are related to transmissions. Let's look at the efficiency. Let's add transmission names, speed ratings. And then we go back to visualization. These signals will be available for each of the generated studies, points of interest. We can then inspect them individually. By selecting each point of interest on the scatter plot, you will see the details of the architecture composition, and by going into the point of interest tab, you will see the residency plots for the entire system, or inverter, motor, and transmission individually. But you will also be able to see the specification of that particular architecture. That sums up my presentation about TGEN. If you've got any questions, please find please direct them at the email address on the screen, or find the information on our website. Thank you.